Hey everybody, this is Gregory from Dapp University. So in this video, I'm going to show you how to build a real-world crowd sale with smart contracts that can be used to raise funds in a real-world ICO. I'm going to show you how to build a production-ready ERC20 token and crowd sale that can be deployed to the Ethereum blockchain in order to raise funds in an ICO. This is going to turn into multiple videos on this channel because I'm going to walk you through each step in the process of building these smart contracts. So be sure to subscribe to this channel to see those videos when they come out. This episode is presented by QuickNode, the fastest and easiest way to run your own Ethereum node. QuickNode lets you run a personal cloud-based Ethereum node in a flash without having to download any blockchain data or keep it in sync. Sign up at quicknode.io today to start running your own Ethereum node in no time. This video is designed for developers who already have some experience with Solidity and are familiar with how ERC20 tokens work. And if you're looking for a more beginner-friendly tutorial, I highly recommend checking out a previous video on this channel that I released. It's an 8-hour tutorial. It's called Code Your Own Cryptocurrency on Ethereum. You can see a link to that here on my Twitter. You can also follow along with me for daily updates on Twitter at Dapp University. And that video now has a full-length article on my website. So if you're new to Solidity and new to Ethereum, I highly recommend checking this out. This is an 8-hour video, and this is a full-length article that talks you through more details than I show in the video, and it shows the code to the token and then walks you through some of the steps to building that. In this tutorial, we're going to rely pretty heavily on the Zeppelin Solidity framework for building the ERC20 token and the crowd sale smart contracts. So Zeppelin is a framework that allows you to build smart contracts on Ethereum, and we'll use this library as a starting point for the smart contracts in this series. And we do this for a couple of reasons. One, we know that they're secure. They've been community vetted and tested. And, that's important because all the code on Ethereum is immutable and can't change. Therefore, it's vital that we get things right the first time whenever we deploy a token or a crowd sale to the blockchain. The second thing is that ERC20 is a standard interface. Instead of writing all of the requirements for ERC20 ourselves over and over and over again, we can use a library like Zeppelin to get us started. So if you're brand new to Solidity or you're not quite sure how ERC20 tokens work, like I said, check out that previous tutorial, but also here's a refresher on the ERC20 interface. I go in this more in depth in that other video that I talked about, but briefly you can just reference this at GitHub. This is the ERC20 token standard. It talks about the functions that the ERC20 token must have, and like total supply, the balance of. It also defines the functionality that the token must have, like the ability to transfer it and approve transfers and things like that. Also, I recorded another video recently on my channel about building your own ERC20 token with Zeppelin. And since I recorded that video, I just decided to kind of go off on that and build out a full-length series on how to build a more complex token and a complex crowd sale that you can use. So yeah, check out those other videos if you haven't, and if you have seen them, that's a good starting point for getting started with this one. All right, let's jump in and start programming. So the first thing we want to do is install the dependencies for this project if you don't have them installed already. The first dependency is going to be Node Package Manager. And you can see if you have Node already installed by going to your terminal and typing node-v. If you don't have it already, you can install it with a command line tool like Homebrew. Install Node. So I've already got this installed, so I'm going to skip this step. The next dependency is the Truffle framework. And just a refresher, Truffle is the framework that we use for developing smart contracts and testing them and deploying them to the blockchain, things like that. You can install Truffle like this, npm install -g truffle. So I've already got this installed, so I'm going to clear that. You can check to see if you have Truffle installed by going truffle version. All right. This will also tell you your Solidity version, which is helpful. The next dependency that we want to install is Ganache CLI. Now, you might have seen my other tutorials where I use, the GUI version of Ganache. Let's say Ganache. You might have seen this before, where this is basically a nice, graphical user interface for our development blockchain. So yeah, that's what Ganache is. It's a development blockchain, and this is the graphical version, which is nice. It's kind of point and click. You can get it started, and it has a nice user-friendly interface here, but I'm actually not going to use the GUI version of Ganache. I'm going to use the command line version or the CLI version of Ganache in this tutorial for a couple reasons. So I'll tell you what those are. Quit this first. The first reason is that we're going to write a lot of tests in this tutorial. And I'm going to be starting and restarting Ganache over and over and over again towards the end of this tutorial in particular when my accounts start running out of Ether. So it's just a lot easier for me to restart Ganache from the command line and not have to worry about it. So yeah, this other reason is I just personally prefer command line tools over graphical tools in many cases, and this happens to be one of them. So you can install the CLI version of Ganache like this, say npm install -g Ganache CLI. And I've already got this installed, so I'm going to clear this. All right, so now I'm going to split my tabs here. And if anyone's curious, I'm actually using tmux to manage my terminal, window division here, and also my sessions. I've used that in a couple other tutorials before, but in case you're curious, you can read more about tmux online. I'm a huge fan. All right, now that we've got our dependencies installed, I'm going to go ahead and create a new project directory. I'm going to simply call this ICO IRL. And that's just going to stand for ICO in real life. All right, now I'm going to cd into that directory. Let's just do this. All right, I'm going to copy this into the other window as well. All right, and now I'm going to just split this pane one more time just to give myself some room. CD that directory. And now I'll show you kind of how to get started with Ganache CLI. So you can start Ganache CLI like this. You just say Ganache CLI. And once this boots up, you've got a blockchain running. This is a development blockchain. And just like the other, graphical version of Ganache, it basically gives you 10 accounts for free. And here are the private keys that you can use. And here's, the mnemonic seed phrase for restoring your HD wallet, gas price, and the gas limit, and the port. So now that that's up and running, we've got Ganache running. So now inside of this directory, we want to basically initialize truffle. So we'll say truffle init. All right, that's downloading and installing. All right, so we've got a new truffle project open. So let's go ahead and open this in Sublime Text. You can use whatever text editor you like. I just happen to be a long-time Sublime Text user. All right, so inside of here, we want to do a couple things. I'm going to actually first just initialize a new Git repository. All right, and I'm going to git ignore. I'm going to initialize a new git ignore file to keep some things out of the project that I don't want. And I'm going to go ahead and add some things here. Say ignore the git ignore file. I want to ignore the node modules that we'll install with node. And I also want to ignore this .env file that I'm going to add later. All right, so I'll go ahead and commit this. Say initial commit. All right, so let's go ahead and install the dependencies that we need for this project. The first dependency is going to be the Open Zeppelin Solidity library, the one that we looked at a minute ago. So I can install that to our project like this. We'll say npm install Open Zeppelin -solidity, and we'll say save dev. All right. And we can see this was added to our package.json file here. Yep, Open Zeppelin Solidity. So I'll save this. And the next thing we want to do is go ahead and pull in a whole bunch of dependencies to kind of bootstrap this project. Kind of dependencies that we'll need for like testing and doing some development work with this project. So I'm going to bootstrap this by going to this Open Zeppelin Solidity repo and actually kind of just ripping off the packages from their package.json file. If we'll take a look, it's got some nice stuff like chai big number. These are things that we'll use for testing. So chai is an assertion library, and chai big number allows us to basically do things with big numbers in the tests. .env, which is what we use for environment variables in our project. Lots of things. So I'm just going to actually copy this, go back to our project, and I'm going to paste them in. And I'm going to alphabetize this. And like this, and this will go before S. All right, save that. I'll go back to my terminal and say npm install to install the rest of these dependencies into our project. And hopefully this will go into our package.json file, or sorry, our node modules directory. All right, now that's done. So let's see. In our project, I also want to go ahead and create a couple things. We want to create a Babel RC file, so we can do some things with ES6. I'm actually just going to paste this in here. This is a preset from the Open Zeppelin repo. You can go to their Babel RC file. See that here. So yeah, this is going to allow us to do some things with ES6, which will be nice. The next thing we want to do is add some stuff to our truffle.js file. And this is, the configuration file for our truffle project. So I'm going to basically reference the truffle.js file from Open Zeppelin as well. They're actually using truffle-config.js for executable to avoid the executable naming conflict on Windows, which I've talked about in some of my other videos. So I'm not going to take all of this just yet. This is some logic that we'll use whenever we want to actually deploy this, but I'm just going to basically take this development configuration and add it to our truffle.js file here. Let's say this is our development network. Actually, this needs to be inside networks. We'll say, we'll just copy this and put it in here like this. So I don't worry too much about these other networks. We'll just have this development network and Ganache specified. So if you'll check, our Ganache CLI is running on port 8545. So we can check in our configuration file that that's correct, and it is. So we'll save this, and I'm going to remove these comments for now. And again, if you're on Windows, you'll want to do this in truffle-config.js to avoid the naming conflict with the truffle executable on your machine. But I'm on a Mac, so I'm going to use this regular truffle.js file. All right, now I think we've got everything that we need to go ahead and start developing our token. I guess we'll find out along the way if we miss anything, and we'll just kind of address those problems as we get there. So the first thing we want to do is actually create an ERC20 token smart contract. And I'll say, we'll actually call this Dapp token. That's the same thing I used in my other tutorial, so we'll just kind of continue along with that. So Dapp token.sol. All right, so inside of this smart contract file, this Solidity file, the first thing we want to do is specify a Solidity version. And you can go to your terminal and say truffle version to see which version of Solidity you're using. This is version 0.4.24. And actually, while I'm here, another note for our truffle.js file. I want to specify the Solidity compiler. I'll do it like this. Paste this in and say this is Sol C, and I want to run the optimizer with 200. So I'm going to save this and close it. So here we want to use Solidity version 0.4.24 to be compatible with this version of Truffle. So we'll go back to our project, and when we declare this Solidity version inside of our smart contract, we'll do it like this. We'll say pragma Solidity 0.4.24. That's right. Yep. And the first thing we want to do is actually declare our contract. So we'll say contract Dapp token. And we'll just say, just open this for now. Save that. Now we could go ahead and build out, all of the ERC20 functions and the ERC20 interface in a smart contract like this. This is what I did in my last tutorial, where I, walk you through step by step, building out an ERC20 token, right? But instead, we're going to go ahead and get started with the Open Zeppelin library and pull in a lot of this functionality for free. So if you look in our node modules directory and go to the Open Zeppelin Solidity folder right here, we go to contracts, and we go to token, ERC20. And what we want to do is use the detailed ERC20 token file. So basically, this is going to give us a full-blown ERC20 token where we can specify the name, symbol, and decimals inside of a constructor. So we don't have to hard code these values inside of the smart contract. We can actually pass them in whenever we deploy this. So we can basically this token, you don't see much here. It's because this token is inheriting a lot of behavior from this ERC20 file, which is here. And this has a transfer from and approve interface, right? And basically you can just follow the chain of command all the way up, right? So basically, we want to take that interface and use it in our contract. We can kind of trace that inheritance up. We also want to just say that this is a standard token. So standard token is going to give us kind of like a lot of the extra behavior, that is available inside of an ERC20 token. So we'll use both of these to kind of get started. You can see this mapping for keeping track of the allowances, things like that. So first we'll go to our token project, our smart contract, and we'll import this ERC20 file like this. So what's happening here is we're importing this from the node modules directory. So you don't want to have node modules here. You want to start assuming that you're in node modules because it pulls them into the project. And we'll say Open Zeppelin Solidity contracts token ERC20, detailed ERC20. And we want to do the same thing for a standard token. We can just say standard token. All right. And now what we want to do is basically inherit from those libraries. And we can inherit in Solidity like this. We say is standard token. And we can separate these by comma and say detailed ERC20. All right. And now inside of here, we'll say constructor. If we go back to the detailed ERC20 token here, we can see that it expects a name, symbol, and decimals. So I'll actually just copy this and say constructor is needs a name, symbol, and decimals. And this can be public. We can separate this onto some new lines. Actually, let's do it this way. And how this works is basically we declare the name of the parent that needs these arguments like this, and we just pass them in. Say name, symbol, and decimals. Okay. So you save that, and that actually is, a basic ERC20 token ready to go. So in order to deploy this and use it on our development blockchain, we need to create a migration script. So we can minimize all this and go to this migrations directory. And I'll create a new file. And I'll call this deploy crowd sale. And we'll eventually put our crowd sale deployment inside of here. But for now, we'll just deploy the token. So let's see here. What we want to do is kind of start with this code. I'm just going to copy this and paste it in. And I'm going to say Dapp token. Basically, just change this up. So actually use const Dapp token equals artifacts.require, and this is Dapp token.sol. So I explained this more in my other tutorials, but basically this is the truffle abstraction for the token, and we're going to require it here in JavaScript and deploy it to the network. So in order to do this, we first need to specify the constructor arguments in Solidity. Here the name, symbol, and decimals. And I'm going to do that like this. I'm basically going to add some configuration. You can basically just add more arguments to this to specify the constructor values. Just say name, symbol, decimals. And I'm just using these as underscores for convention to show that they're the constructor arguments in Solidity. You don't have to do that. But I want to define them here. So const name, it'll say Dapp token. Say const symbol equals, we'll just say Dapp, and const decimals. We'll call this, let's say 18. We'll use the same decimal value as Ethereum, or as Ether. So what I want to do is basically, yeah, this works for now. We don't need to optimize this anymore. We've got everything we need. So I'm going to save this, and we'll go to our terminal. And first, let's just see if it compiles. We'll say truffle compile. All right, looks like it's working. Okay, that worked. So now let's try to migrate it to the blockchain. Say truffle migrate. We can watch this action in real time over here in Ganache. And it looks like it worked. All right, so now let's try to go to the truffle console and see if we can actually interact with this token. So what we want to do is get a deployed instance of it. So we'll say const token. Well, actually, let's do it this way. We'll say Dapp token, which is available here. We'll say deployed. We'll say then, and we'll pass it a function. We'll say this will be the token. Token equals t. Oops. Sorry. I need to pass this some. All right, so we've got a deployed instance of this token. I can basically say like, token address. All right, and that worked. And, I can also say, like token name. All right, let's get this Dapp token. Token symbol. Dapp. And token decimals. All right, we can see that returned a big number. We can actually, inspect the numerical value like this, token decimals. And then then pass it a function. Let's say value, and say like console log v2 number. Oops. All right, so 18. All right, so that's all I got for today, guys. I'm going to go ahead and commit this. Call this video 1. So at some point, I'll have this project up on GitHub, and I'll put the link down in the description below. You can go to this commit to see the progress at this point in the video. Just to recap, we built out this Dapp token with Open Zeppelin Solidity library as a standard token. So in the next video, we're going to actually start writing some tests inside our test directory, and tests are how we're going to really drive this tutorial series. I'm going to kind of take it as a test-driven approach. Tests are going to our tests are going to be how we ensure that our token and crowd sale are working the way we expect them to, and yeah, we'll also we won't be using a standard token here. We're actually mint tokens in this crowd sale. So we'll be using a mintable token, and I'll explain how all that works in detail throughout this tutorial series. So yeah, I hope you liked this tutorial. Be sure to subscribe to the channel for the next video in the playlist whenever it comes out. And until next time, thanks for watching Dapp University.